Geokno, an experienced company which had started from IIT Kanpur, was entrusted with undertaking the aerial Lidar survey. But before the survey could begin, two important activities had to be undertaken. These were taking permissions from DGCA and Ministry of Defence and establishment of a robust ground control network to ensure required accuracies.
Once you get the work order, the very first thing that we do in India is we apply for the permissions of that area.
While permissions were being taken, the ground team started the ground control. In the study area, the ground team identified the available Survey of India benchmarks. These benchmarks were used for establishing the vertical control through the process of double tertiary leveling. Horizontal control was established through a triangulated network of 64 master control points. This was further densified through 232 secondary control points. Out of these 232 secondary control points, 102 points were used as target points to be used for checking the accuracy of the data. As Lidar does not get returns below water, the ground team also undertook hydrology survey for river areas. With the permissions in place and the ground control completed, the actual data capture with aerial Lidar sensors fitted in the helicopter started.
And we use the Eurocopter in this case. Then we have a way to fit our system, our Lidar, our camera, IMU and the GPS all along with the computer in a Eurocopter.
Lidar works on the principle of light detection and ranging, where Lidar scanners scan the ground by firing laser pulses as the helicopter flies.
As you know, the procedure for collecting the Lidar data is very simple because we are flying the Lidar, we have got the laser scanner there, which is firing the laser pulse, and wherever it is hitting, it comes back to you. You measure time of travel, as well as you know in which direction this laser pulse was traveling. Because I have a GPS here, it gives me the position of this platform. I have also an IMU here, which tells me the orientation of the platform, as well as the accelerations by which this platform is moving. So using IMU and the GPS, it is possible for me to know exactly where was the aircraft while it was firing the laser pulses. So that is possible for me, as well as I know the orientation of the aircraft. So if I combine the distance, I combine those orientations, I can generate the coordinate of the point in the ground in the same coordinate system which is being used by my GPS, and simultaneously we are capturing the photograph also.
The first flight for the aerial data capture is the calibration flight.
The meaning of the calibration flight is before we actually capture the data, we do a calibration for certain area, and on that calibration we check the accuracy of the data so that my sensors are fitted properly. If there are some misalignments, we correct for that.
After the calibration, the process of actual aerial data capture starts. Flight planning algorithms are used to determine the flying parameters such as height of data capture, velocity of helicopter, and scanning rate. This ensures that the raw data is captured with Lidar point density, accuracy, and orthophoto resolution as per project requirement.
The entire data is captured. Every day we would check the quality of the data so that we are not missing any area, our data is complete. And also every day in India it is particularly the data would be security sealed by the security officer in the field.
After the data has been captured, pre-processing of the data starts.
So I use the IMU information, combine that with the GPS information so that I know now the trajectory, where exactly the aircraft had gone. So these are the pre-processing steps that we are doing.
The Lidar data generates ellipsoidal heights, but for undertaking design, data is required to be in main sea level heights. Hence, During pre-processing, the Lidar ellipsoidal heights are converted to main sea level heights with the help of vertical control established using Survey of India benchmarks.
So at this stage, the data are available as the last file. And also I've got the raw photographs. Then this particular data is again security verified. Then whichever is the vital installation there, those are taken away. The rest of the data becomes available for me for further processing.
After security vetting of the data, the post-processing of the data to generate the final deliverables starts.
At this stage, the data points, they do not know what they are. Whether they belong to the field, whether they belong to the tree or the house or whatever. They are just coordinates, northing, easting and altitude. Then we run algorithms on top of this data. Those algorithms are able to separate the ground points in one layer, the vegetation in another layer, bigger vegetation in another layer, houses in another layer, transmission lines in another layer, and so on. So what we have now, we have so many layers. Also using the digital elevation model that we have generated and the photograph that we have now, we create an orthophoto. So for complete area, I have now an orthophoto mosaic. Next step is using this information, these separated layers of different features, orthophoto, then we create the GIS layers. Because ultimately the client is interested in the GIS layers or they want the AutoCAD.
The post-processing of data results in final deliverables of the project. These are bare earth digital elevation model of 1 meter by 1 meter grid, seamless orthophoto of the entire stretch, 3D topography map in 1:2000 scale, contours with an interval of 50 centimeters, cross sections and plan and profile.
Within